welcome back to our third and final video going over the review for the Unit 2 chapter, or the Unit 2 test on modeling and exponential functions. So in problem number 6, you are given an exponential function, f of t is equal to 2 times the quantity 0.25 raised to the t plus 3 minus 4. You're also given the graph. And you're asked to describe the transformations of the graph from the parent function. So I just want to remind you that this number right here is our base. It's not part of the transformations. Remember, our transformations are a, h, and k. And so just to kind of identify them, my a value in this case is the coefficient out here in front. That's going to be a 2. And that's going to tell us two things. That's our vertical dilation, and it also tells us whether or not the graph has been reflected. And in this case, since it's positive, the graph has not been reflected, but it does indicate that it's a stretch. So it tells us that the graph has been vertically stretched. Okay. The number in our exponent that is corresponding to the value of t, that's going to correspond to our h value. And if you remember, with our parent function, so if I were to write the parent function, we know it's going to be, well, here's my parent function, b to the x. If I transform it, it's going to look like this, a times b to the x minus h plus k. So if you remember in the formula, that quantity x minus h tells us that we're always doing the opposite of whatever h is. So if you have the quantity t plus 3, it actually means that h is a negative 3. And so that's telling us that the graph is going to be scooting to the left, or shifting left 3 units. The number on the outside corresponds to our value of k. And notice that in the formula, k is just, it's plus k. So we don't have to worry about changing the signs. So here, k is a negative 3, which tells us actually that we're going to be shifting down 4 units. Now, you don't have to actually identify the values of a, h, and k, but you do need to recognize that the 2 in front is going to stretch the graph vertically. If the quantity says t plus 3, it's actually shifting us in the opposite direction. So remember, inside, opposite, outside, same. So the number on the inside, or that's going to be associated with x, and remember, since this is up in the exponent, when you type it into the calculator, you're going to want to have parentheses around it. And so inside opposite, meaning inside the parentheses, we're actually shifting it in the opposite direction. That's why it's moving left. And then the 4 on the outside tells us to shift it down. Okay, the next question asks us to state the domain and the range. One thing you want to remember is that for an exponential function, the domain is always going to be all real numbers. That's going to be true for every exponential function. Okay, and the easiest way to write that, there's actually a symbol, it's like a double R, that says all real numbers. But you may also see it written as an inequality, where we're saying x is essentially between negative infinity and positive infinity. So just know that there are lots of different ways that you can express all real numbers. In terms of the range, and I apologize, I'm running out of space here, the range is actually going to correspond to our horizontal asymptote. Remember that every exponential function also has a horizontal asymptote. And the horizontal asymptote is always going to correspond to your value of k. So your horizontal asymptote is always going to be y equals k. So in this case, it's going to correspond to y equals negative 4. And since the graph is all above negative 4, that tells me that for my range, all my y values are above negative 4. And notice that I'm not including an equal sign with the range. So, and that's because the graph never actually touches the asymptote. It stays above it at all times. It gets closer, but it never actually touches it. So the range in this case is going to be determined by where that asymptote is. So one of the things to remember, just in general, and let me do this, let me just kind of do a quick picture for you. So if I have an exponential function, and it doesn't matter if it's growth or decay, but if I have a function that looks like this, then I know that and actually it doesn't need to be, let me change this actually, sorry. Let me just make it a little bit more general and not actually even put on any axes. So let's say this is my horizontal asymptote. So this is going to correspond to y equals k, my asymptote. Okay, so if my function is like this, then I know my range is going to be that y is greater than k. But if I have an exponential function that is flipped, so let's say the a value is negative, that means it's going to be reflected and it's going to be going down like that. This function is going to have a range where y is actually less than k, and that's because the graph falls below the asymptote in that case. Okay. The next thing you're asked to do is to determine the x and the y intercepts. This is something that you can't see, you can see where they are on the graph, but it's impossible to find the exact values using the graph. So to find an x-intercept, we always let y equal 0. And if you think about where you can enter in y equals 0, we have to go to our y equals screen. So I've got a couple things that I need to turn off. Notice that I have a plot on. I'm going to press enter to turn that off. And I'm going to go ahead and enter my function, 2 times the quantity, 0.25. And I want to raise that. And just get in the habit of putting parentheses around your exponent. So even though we're using the variable t in our problem on my calculator, I'm going to use an x. Now with the new calculators, make sure you come out of the exponent before subtracting 4. The next thing I want to do is enter in the equation for y equals 0. I can do this on a Zoom standard window or even a Zoom decimal window. So if option 4 will give me a window that's a little bit closer to what we see on our paper. The only problem is I can't really see where the y-intercept is, so maybe it will be a better idea for me to do a Zoom 6. That's our standard window, which basically takes us from -10 to +10 on both the x and the y-axis. So if I'm interested in finding the x-intercept, basically what I've done, and you can't really see it on my calculator, is I have plotted the equation y equals 0. So I already have my function. I've also graphed the line y equals 0, even though it's kind of covered up right now by the x-axis. And essentially, I want to find that point. That's going to be my x-intercept. It occurs when y equals 0. So I just need to find the intersection of those two graphs. So if I hit second trace, notice option 5 is my intersect option, and we've done this before. Hit enter essentially 3 times. These are the only 2 graphs on my calculator. So if I hit enter 3 times, wait until it actually tells you that it's the point of intersection, and it gives you the x value. So my x-intercept is -3.5. To find my y-intercept, then I'm going to let x equal 0. And that's a little bit easier because I can do that in a bunch of different places. I can also use my trace option. So if I hit second trace again, notice the very first option is value. This is where I can enter in values for x. So if I press 0, I can actually look on my graph and see that the value of y, or the y-intercept, is -3.969 if I round. Okay. Another way to do that would be to go to your table. If you hit second graph, it'll take you to the table. And so you can either scroll until you get to where x is 0, and that'll tell you that the value is -3.969. And those are probably the 2 easiest ways. The other thing you can do is just plug 0 into the equation. So if you go to your home screen and just type in 2 times the quantity, 0.25, close that out, and then raise it, and then in parentheses you'd want to do basically 0 plus 3. And then come out and do your -4. And you should still get the same thing. Okay, so that's how you find your x and y intercepts. Those are 2 skills that you learn in Algebra 1, but we just haven't seen it a lot with the exponential function. So I wanted to show you how to do that on the calculator. All right. Number 7, this is the newer stuff, but actually it's really the same skills that you've been doing since Algebra 1. It's just now presented to you in a different way. So now it's just presented to you as function notation instead of as y equals. So each of these functions, this is the same thing as if I were to say y equals 2x squared minus 1. And if I wanted to distinguish them, I could call this one y1. I could call g y2, and that would just be 10 to the x. I could call h, I could call that y sub 3, and that would be 5x plus 2. Okay, so that's all I'm asking you to do. In letter A, where it says to take f plus h of x, it's not asking you to add f and h together and then multiply by x. So you have to recognize the context here. In this problem, those parentheses do not mean multiplication. They represent function notation. And so we do something different. So in letter A, if I'm adding my functions f plus h, this is the same thing as taking f of x and adding it to my function h of x. Or if I wanted to use my y1 and y3, that's the same thing as me adding y1 plus y3, if you want to look at it that way, if that's easier. But you do really need to understand function notation in this course and beyond, because most higher maths refer to function notation. When you're adding, I'm essentially going to take a look at my f function, which is 2x squared minus 1. And I'm adding that to my h function. Well, my h function is just 5x plus 2. And now I'm just adding like terms. You guys know how to do that. So 2x squared, I want to look to see if there are any other terms that are alike to combine with it. And since there's no other term that involves an x squared, there's nothing else I can add to that. So my answer is going to have a 2x squared. So I've dealt with that term. If I'm writing in standard form, then the next thing I want to talk about is my x term. In this case, that's 5x. And then lastly, I want to add my numbers. I have a negative 1 and a positive 2. When I put them together, I'm going to have a positive 1. Now notice in this case, the term that I'm evaluating is over x. And notice how both of these, the answer also includes an x. In all of the other problems on the page, notice that I'm evaluating for a value, for a number. So in parts B, C, and D, my final answer is just going to be a single number. In letter B, if you're asked to evaluate g of 2 minus h of 5, that's essentially taking my g function and plugging in a 2 for x. So it's easier with all of these, I think, to do them in pieces. So to first figure out what g of 2 is. Well, if I plug a 2 into my g function, that means I'm trying to figure out what 10 squared is. Well, 10 squared is just 100. And then the next thing you're asked to do is h of 5. And so if I go to my h function and plug a 5 in, that's 5 times 5 plus 2. Well, 5 times 5 is 25. If I add 2 to that, I get 27. Now what I'm really asked to do, though, is g of 2 minus h of 5. Well, g of 2 we said is 100, and h of 5 is 27. So I'm just going to do 100 minus 27, and that's going to give me 73. So notice how this time I've got a number as my answer. In letter C, I'm asked to evaluate h minus f evaluated at 2. That's essentially what this question is asking me to do. That's the same thing as taking h of 2 minus f of 2. Let's figure out what those values are. H of 2, if I go into my function, is just going to be 5. I'm replacing the x with the 2 plus 2. Well, 5 times 2 is 10 plus 2, that's going to give me a value of 12. And my function f of 2 is 2 times 2 squared minus 1. Use your order of operations here, or you just plug the whole thing into the calculator. I'm going to do my 2 squared first. That's 4. 4 times 2 is 8. Minus 1 gives me a 7. And so now if I want to do h of 2 minus f of 2, I'm looking at 12 minus 7, and that gives me 5. Letter D, this is what you have to be able to do. It looks more complicated than it really is. Let's break this up. This quantity here is asking me to do f times g evaluated at negative 1. Another way of writing this would just be to say f of negative 1 times g of negative 1. And now if I look at this quantity, I'm asked to subtract f divided by h evaluated at 10, or simply f of 10 divided by h of 10. So what I'm going to do off to the side here is I'm just going to evaluate each one of these little pieces. Okay, so f of negative 1, I'm going to plug a negative 1 into my f function. 2 times negative 1 squared minus 1. Well, negative 1 squared is a positive 1. When I multiply that by 2, I get 2. And 2 minus 1 gives me 1. You can also just plug that into your calculator. I need to evaluate g of negative 1. So I go to my g function, 10 to the negative 1. Well, we haven't really talked about negative exponents, so let's just go ahead and evaluate this on the calculator. It's 0.1. I need to evaluate f of 10. So I'm going to go to my f function, and I'm going to do 2 times 10 squared minus 1. I'll show you. You can just do this on the calculator. 2 times 10 to the second power. Make sure you pull your cursor out of the exponent, minus 1. And that gives us 199. And finally, h of 10. So with h of 10, we've got 5 times 10 plus 2. Well, 5 times 10 is 50, plus 2 gives me 52. And now I'm essentially just going to plug in these numbers for each of the different quantities. So f of negative 1 we said was 1. I want to multiply that by g of negative 1, which we said was 0.1. And then I want to subtract f of 10, which we said was 199, divided by h of 10, which we said was 52. Okay? I'm going to do this right on my calculator. Let me just make sure that that does look like a time symbol and not another decimal. So this is what I'm going to type. 1 times 0.1 minus, and I'll put my fraction in parentheses, 199 divided by 52. And we get negative 3.727. Okay? And that's all you have to do for that problem. It looks a lot harder than it is. So my strategy would be to break it down and rewrite it so that you're just evaluating each function at a time and then putting it all together as one big answer. If you try to do it all at the same time, chances are you're going to make mistakes with respect to the order of operations and not putting grouping symbols where they're supposed to be. I hope this was helpful. Obviously, you can still come in for Bulldog Block either Wednesday or Thursday to get extra help. Good luck.